Hi, everyone. Okay. Okay. Nice to see all of you. I hope everyone's doing well. If you can check in a minute with like a say hello or send a text or something like that, so I know that we're communicating.
Good morning.
Hi, Kyle. Nice to see you. Okay, so Kiana, I saw that you are here. Katana, how are you, Kiana?
I'm doing great.
Kiana, I got your late pass request, and at this time, you don't need to submit any more late passes for any work from chapter 5 onward. So I just would like people to start to submit assignments because I think we're going to run into some real time problems here if we don't get moving. And Katana, nice to see you. You're always so on top of things, and that's terrific. I hope it's helpful to you too. And Katana, just a text or a greeting, please.
Yeah.
So I have to say that Katana last week caught a mistake that I had made. And it was a mistake that I made because I was trying to make the process of the independent t-test simpler. But I tell you, if you catch a mistake that I make, that is the best thing that can happen because it shows like what I liked about it is she was confident in her answer. And so I checked back in mine and I saw that a process that I had sort of popped in there to just move one step was an errant process. So I appreciated that very much. And any of you, you know, I try to be really careful about this, but if you ever see any kind of a mistake I do in class, out of or in what you're seeing, just please let me know and you'll get some credit. She got credit for the practice. I can't remember now, but anyhow.
Is it the number 3 one?
No, it was related to, I removed the content as soon as I realized it was errant. So there's no longer any errant content up. But if you see something that you think is wrong, you can let me know. Maybe there's something else I missed, but I really...
On the practice one, I noticed that there was a question that was different from the practice problem for
Oh,
the enter key.
you mean the question was different? So the key, so I posted the wrong key for the problem?
Yeah, added like an extra person or something on there.
Okay. All right.
I think that was question 3.
There was an extra person on there. Okay, well, I'll take a look at that. That one I didn't see. That wouldn't be like exactly a mistake in the key. It would be it would be like the problem being not the same as the one that you were given. So let me look at that. And you're talking about the practice problem number 3. And so in general, you guys who are just staying in here, you're going to do just great in this class. And what I hope to do today is go through 3 problems. That's my goal. Go through 3 problems with you in the independent samples t-test. And then hopefully I already recorded a couple of nice new examples using Excel, and I posted them up. And I've also prepared a template for you for if you decide to use Excel. So the first problem that I'm going to solve, we'll do on paper. And after that, I'm going to show you in Excel. So I'm hoping to get through 3 problems today. It's usually for me to do it alone. It's about 15 minutes or, maybe 12 minutes. It depends on how much I have set up. It depends on if I've tried to narrate what I'm doing. And so if I'm not narrating, these can be pretty quick. But if I'm narrating, they take a little bit longer. So let me just jump in here and get the problem we're going to work on. I have it in Excel, but I'm going to show it to you first on paper, and then the very same problem in the spreadsheet. So I'm going to grab the problem so we can show you first in paper and review the concepts. And I just need to change my view here and share my screen. So here we go. Doris, how are you doing?
I'm doing good.
Good. I miss you here today. It's always nice to
Yeah,
have
I didn't renew my Warrior ID.
Yeah, I figured something like that. Yeah, to come on campus, which most of you are probably going to do next term, you need to have your ID updated with us. They give you a special sticker when you show that you're vaccinated. So that's what you'll need to do, just so you're aware of that. If you don't do that, then they won't let you in the building. Okay, so I'm going to just grab this and so we can use it in our whiteboard. Sorry, they're taking me a second. They changed the whiteboard app sort of aggravatingly so that now, oh shoot, hang on. I have the solved out version here. Okay, I think I'll just copy it by hand. All right, so in any case, what we're going to be solving is this question. Do puppies trained with praise and affection show better responsiveness than puppies who are trained with punishment? Yeah, this is what they changed. So everything is really different. So it's a little harder for me to do the work that I used to do in here. All right, so here's the problem. So a pretty simple problem. When someone told me really helpfully that parsing out the problems was sort of a pain, I did go through and make the problems pretty straightforward so that we're not stuck on that particular barrier. So here we go. So as you'll recall, first of all, in the independent t-test, we are comparing 2 independent samples. And our independent samples have, and so what we're basically knowing is we're asking the question, do the puppies who are trained with this praise and affection, so we have sample 1, so we'll call it group 1 or sample 1. And then we have show better responsiveness to people than dogs trained with punishment, and this will be sample 2. And so what we're doing in a nutshell is we're comparing the mean for sample 1 with the mean for sample 2 by subtracting. So what we're looking at then, when we subtract something, we get a difference. So in a nutshell, we're comparing this difference with the comparison distribution of a whole bunch of sample 1s minus sample 2s to get the population difference. So we're looking at a whole bunch of these. So many of these samples that are drawn and their differences are plotted. And so we're looking at what would we get if we had a whole bunch of these samples where really nothing had been done between sample 1 and sample 2. So there's just a whole bunch of randomly selected samples we drew from the population hypothetically. We subtracted one from the other and we plotted the differences. And that's what we're comparing to. So let's go through this problem today then and start with our basic steps. Let me change the size of my ink here, so it's a little bit smaller. All right. So, and I also like to use my colors a little bit carefully. And so we'll stay with, I think, this width. And so I'm going to start by describing the problem in step 1. So we're going to start the way we normally do with step 1. And we're going to parse the problem. And so we do our populations the same way. Let's see if I can write a little more neatly here. So population 1, and we're working at our main population is the puppies trained with praise and affection. So puppies, we have to always list what we're working with. In this case, our individuals are puppies trained with praise, affection. And population 2 is puppies trained with punishment. What's the dependent variable in this problem? Can anyone type it in the chat? What are we measuring or counting in this example?
Is it responsiveness?
Yeah, exactly. We're looking at responsiveness to people. So we're looking I don't know what this variable looks like because we're not told. Responsiveness. And so this is the dependent variable. I'll put 2 lines under it. And then we have this word better, and that suggests a direction. So when we look at the tails, we'd suggest 1-tailed high. And then we're going to just write our hypotheses up in short form now because we've come far enough on this. And we can see that our initial hypothesis is that the mean responsiveness, that's what this mu means, for population 1, that's what that little subtext means, will be better than the mean responsiveness for puppies trained with punishment. And so that is our research hypothesis. I should always put H1 here. And then our null hypothesis is that the mean responsiveness for puppies trained with praise and affection will be equal to the mean responsiveness for puppies trained with punishment. And you could also write, if you wanted to, which would be actually more accurate, but either are acceptable, that the mean responsiveness for puppies trained with praise and affection will not be greater than the mean responsiveness for puppies trained with punishment. So that's what we're looking for, and you can do your own step 1 just this way. Step 2, in most of our examples, is this big step. And in step 2, we have to describe the comparison distribution, and we can shorten this down a little bit at this stage too. We're still looking for the same information. We're going to be using a t distribution because we don't have any known characteristics for the comparison distribution. So we're going to be using the t distribution. And the center of that distribution, so I'm just going to write this out in a sentence, with a center mean, and this is a mean difference score. Let me just see here. The t distribution, I'm going to write this a little more clearly. Let's write the t distribution for differences between means. That'll be more clear. For differences between means. So this is right here, what we just said our comparison distribution was. We were comparing mean 1 minus mean 2 of our sample with mean 1 minus mean 2 with our population. In other words, we're going to get mean difference. And so let's be clear about that. And so the t distribution for differences between means with mean difference equals 0. We assume that if we took all these differences and we plotted them, their average score would be 0. In some cases, the mean 1 would be higher than mean 2. In some cases, the reverse would be true. If we average it all up, we get 0. So that's what we indicate for our center. And our spread, our shape is still going to be normal. We're not expecting a skewed distribution of any sort. It's a t distribution that's basically normally distributed. And this is the hard part. So what we're looking for is the estimated standard deviation of difference scores. And this is what we have to calculate. And so we're going to leave a blank here, and we're going to fill this in a little bit later. I'm going to write out the next steps so that we save room. So step 3, we just have to find the cutoff point. And for that, we're going to look it up the way we have done. We're going to look up our critical value for the t distribution. And we need to indicate, let me move, I have a little box on my screen here, I'm just going to move. We need to indicate our p-value, and our p-value is shown to be 0.05 with p equals 0.05. So we're going to look that up. And then we have to put our degrees of freedom. And this we're going to fill in a little bit. So I'm going to put a box here too. And then we have to put our tails, one-tailed high. So you guys are really familiar with this by now. In step 4, we're going to calculate the t-score for our differences. I'm writing this out. You don't have to write this out necessarily, but for the sake of clarity in our examples, I'm writing it out. And we're going to calculate that similar to how we've always done. We're going to take the mean for the puppies, sample 1, the puppies who are trained with praise and affection. We're going to take the mean responsiveness for the puppies who are trained with punishment. We're going to subtract them, then we'll have that difference. And we're going to divide by the standard deviation, just as we always do. That's going to be that standard deviation for difference scores. It's the same as the estimated standard deviation. It's just for these differences between means. And so we'll leave a blank here. And in step 5, we're going to make a decision and draw a conclusion. So these are the information that we're going to fill in. And when you're doing your problems, it's a good idea to organize them in a similar way. So have these up above, and we get into so much detail now that it's helpful to just have your calculations in one area and your solution in another area clearly indicated, and that helps you and it also helps me. So now we have to get our data. The data are provided to you in the problem, and I'm going to see if I can get them copied out. Otherwise, I'm just going to write them down for memory, and that's okay too. So going back to the problem as I had it written, I can see that we have 6 puppies with 10, 6, 7, 9, 12, 7. Let me see if I can copy it and paste it in, but I've had a little trouble with this in this new whiteboard app. See what we get here. Yeah, it's not willing to do that there. So I'm going to just write this down and leave myself some room. I'll use green for sample 1. So let me write up here, group 1. And I'm going to make sure I know what I'm talking about. This is the affection group. And let's go ahead and get the raw data. So we had 6 puppies. I'm just going to abbreviate P1, P2, P3. Let me drag it up here. Puppy 4, puppy 5, and puppy 6. See if I can get my grid back. I often get a grid here, but that's another thing that they eliminated in this new app. So let me just see. Here we go. I'll get my grids here. That'll be better. That'll make my work a little neater. Okay, and the scores that we had for this group were, you guys can help me remember if that's possible, 10, 6, 7, 9, 12, 7. Ten, 6, 7, 9, 12, 7. So this is the information that you would be provided. This is what I was provided. And I didn't leave room here, but this is X. Those are the scores. And in group 2, let's get that written in 2. I think we had a different number in our sample. So this is a little bit different kind of problem. And in our sample, we had, nope, we still had 6 puppies and 7, 4, 6, 5, 8, 6 for their responsiveness scores. 7, 4, 6, 5, 8, 6. We'll do these over here in blue. See if I get it right at the end there. So 7, 4, 6, 5, 8, 6. And this is again puppy 1, puppy 2, puppy 3, puppy 4, puppy 5, and puppy 6. And these are the X scores for group 2 punishment. All right, now we're ready to begin our work. So the first thing we have to do when we start with raw data like this is we do what I call the basics. So what is known? What can we know right away? So we'll do the basics here. Or what can we easily calculate? And what we can easily calculate, first of all, is n. We can count them. We know that n equals 6. Degrees of freedom? Degrees of freedom is n minus 1 always. And so that's 5. So we have 2 things already quite easily. We can fairly easily calculate the mean for sample 1. I should always put the 1 here. The mean for sample 1 is going to be the sum of all of these divided by 6. So we can just sum them up. Let's see if I can do good mental math because I didn't look at it. So 10 plus 12 is 22, plus 9 is 31, plus 14 is 45, plus 6 is 51. I bet I got that wrong. Did anyone calculate that ahead of me? I don't think I got that wrong. Oh, I don't have the sum written there. So let's just trust the math here that we have 8.5. All right, so let's go ahead and write the 8.5. We know we're going to need sum of squares. We always do. This is the sum of squared deviations, and we can calculate that. We know it's just the sum of each score minus the mean for sample 1, divided by n for sample 1. Excuse me, divided by, all right, there we go. I write my formula down wrong. And we know that the sum of squares is just the sum of all those variables not divided by n. I'm getting ahead of myself and using an old formula. The sum of squares is simply x minus m squared. And then we can go on and do one more step, and that is to calculate the variance. And that is sum of squares for sample 1, because we're going to estimate it for the population we divide by degrees of freedom. So we can get all this information right off the bat. So let's just run these calculations fairly quickly. We know the mean is 8.5, so I'm going to make a column for mean the way I prefer to, and we'll write 8.5. And I'll just write it down the line here. All right, and now we just do the subtraction. We calculate the deviations, which is x minus m. So 10 minus 8.5 is 1.5. 6 minus 8.5 is negative 2.5. 7 minus 8.5 is negative 1.5. 9 minus 8.5 is 0.5. 12 minus 8.5 is 3.5. And 7 minus 8.5 is negative 1.5. We have to then do our next step and square these deviations so that we can figure out our sum of squares. So let's just do our deviations squared. 1.5 times 1.5, and I'm going to take a look so I don't make any calculation errors. All right. $2.25, 6.25. I'm going to check back when I'm done and make sure I get this right. 2.25, 0.25. 3.5 is 12.25 and 2.25. And all I did is take 1.5 times 1.5 to get 2.25. And I did the same thing for each of these. And so we end up with all of these deviations squared. We already know that the sum of squares is the sum of all those squared deviations. And so if we add all these up, I believe we get 22.5. I'm going to take a look here to be certain, and it's 25.5. So our sum of squares equals 25.5. Is there any question on how we got the sum of squares? We've worked with a sum of squares a fair bit, but sometimes these can get foggy again. Does this all make sense?
Yeah.
Thanks. Thanks. I can't tell who answered, but thanks for responding. If anyone thinks it doesn't make sense, you should speak up also. And now we could go right ahead and calculate the variance just as we always do. So 25.5 divided by 5, and we get 5.1.
1.1.
Yeah, thanks for helping on the math here. All right, we'll do this. Let's do the same for the other set. Let's get the basics, and then we can do with a part that's new. So the basics for our group 2, the punishment group, the responsiveness was measured for each puppy, and the scores for our basics. Let's go ahead and get what we can. So we know n equals 6, degrees of freedom equals 5. We know the mean equals, let's see if we can do it in our heads again, because I didn't look yet. So 12, 25, 29, 36. Divided by 6 is 6.
6.
Make sure okay, good. Thanks for checking me. All right, now we have to write our mean in here. 6, 6, 6, 6, 6, 6. Let's calculate our deviations. This time I'll head the column x minus m 2, since that's what we're actually doing. And we have 1, negative 2, 0, negative 1, 2, and 0. And if we square these deviations, move my little box here, let's write x minus m squared, m2 squared. 1 times 1 is 1, negative 2 times negative 2 is 4, 0, negative 1 times negative 1 is 1, 2 times 2 is 4, 0 times 0 is 0. By the way, I really encourage you to work these along like someone is doing. I think that might be Doris, because first off, you can catch me if I make a mistake, which is really good for you to do. And secondly, it will really just help you if you're doing these as I do them. So M2 is 6. We know the sum of squares for group 2 is going to be the sum of all of these, which is 4 plus 1 plus 4 plus 1, which is 10. We know that then we can go right ahead and calculate our estimated variance, and that's going to be 10 divided by degrees of freedom, which is 5. So a nice easy number we get to. All right,
Yeah.
now when we work with independent samples, we need to do one more step. And I'm going to put some data in the middle using a neutral color because we're really looking at one comparison distribution, not two. And so we're going to use the existing data to make a comparison make data for the comparison distribution. So we have to do some combined information. So first off, we need something called degrees of freedom total. I'm just trying to think of how to organize this here. I think I'll put it right here. Degrees of freedom total. And this is simply df1 plus df2. And so in this case, let's do it down here. We get df1 is 5 plus df2 is 5 equals 10. So our degrees of freedom is 10, and it's this number that we'll use when we look up our cutoff point later, because we have one comparison distribution, and this is how many degrees of freedom it has. We're also going to do a little bit of a weird calculation. I like to do it this way because it makes more sense. What we have to do is eventually what we want to do is we want to get something called a pooled variance. So I'm going to write S squared for variance, and I'm going to write pooled. And what this means is we want to figure out a variance that represents the variance in both of these samples. Which variance should we use? Should we use this 5.1 that we have in sample 1? Or should we use the 2 that we have in sample 2? What are we going to do? So we could just average them out. And when sample sizes are equal, we can in fact average them out. But it's better not to get too trapped in that because sometimes we don't have the same number in sample 1 as in sample 2. So let's just get into the habit right away of calculating out what proportion of the total degrees of freedom are from sample 1 and from sample 2. And so let's do this by figuring out a variable that I name percent. And it's a super easy calculation. I call it %1. I abbreviate it PCT1. And so I'm figuring out what percent of the population or of the sample is represented by population 1. So I take degrees of freedom for sample 1, divide by DF total. And that gives me a nice percentage. And in this case, if I take 5 for the degrees of freedom in sample 1, divided by 10, I get 0.5, 50%. And that makes perfect sense. And we know that that will be the same for sample 2 because the sample sizes are the same. So the percent, so PCT2 will be the same for sample 2. So it's going to be 5 divided by 10. 5 divided by 10 equals 0.5. So now we have a new variable called %1 and %2. And this is easy to calculate right away, but this is a new variable that we haven't worked with before. So I'll put a circle around it. And I like to do it this way because to me, it makes a lot of sense in terms of what we're doing. So now we're going to figure out what variance to use for our sample of mean differences. So that formula that we use for the variance pooled, I'm going to just write it down a little lower so I have a little more horizontal room here and get my purple pen back out for the data in the middle. So let's put our formula for variance pooled. Variance pooled, we're going to figure out what to use for sample 1. So we're going to take the percent for sample 1, and we're going to multiply it by the variance for sample 1. And then we're going to add that to the percent for sample 2 divided by the variance for sample 2. And that'll give us a nice balance. We're going to use half the variance from this one, half of this 2, and we're going to use half of this 5.1. So it's sort of like the average, but we've weighted it based on how many are in the sample. And in this case, this would bring us to 0.5 times 5.1 plus 0.5 times 2. And in this case, if we calculate that out, anyone can go ahead and do this. But what I came to is 3.55. My computer seems to be strained today. I don't know why. All right, so this is going to be our variance pooled. And now, but remember, we still have to, this is for the distribution of individuals' mean scores, but we actually have to use the sample size that we're given. And so we have to clarify that in our problem. So next we have to calculate the distribution of means, and we have to do that for each sample. So let's go ahead and calculate the distribution of means for sample 1. And in this case, we get, we're going to use the pooled variance. So we're going to the distribution of means for sample 1. Variance for the distribution of means for sample 1 is the pooled variance. And then we do the same way we always have. We divide by n. So in our last examples, we just took our variance and divided by n. We're doing the same thing, but we're using the pooled variance. And so in this case, it's 3.55 divided by 6, and that equals, anyone want to call it out? I got, I always check and make sure I did my formula right, and I got 0.591667. 0.591667. So there we go. Now we have the variance for the distributions of means for sample 1. We do the same thing for sample 2. So we take our variance pooled. So the variance for the distribution of means for sample 2 equals the variance pooled divided by n, and that equals the same thing, 0.591667, because the n was the same. But if the n was different, then this would be different. And so now we're ready. Now we can go ahead and finish this process and calculate out our S for different scores. And then we're just about done with this problem. We do that. So all we have to do is sum these two. So the variance for differences between means is the sum of the variance for the distribution of means for sample 1 and the variance for the distribution of means for sample 2. And in that case, that equals 0.591667 plus 0.591667, and that equals 1.18 with repeating threes. .1833 repeating. And then we just do our final step. We don't need the variance. We actually need the standard deviation for the distribution of differences between means. And that is just the square root of the variance of different scores. And that equals the square root of 1.1833. And if I go in and figure out that formula, it is 1.0878 113. 1.0878113. 1.0878113. And up in my answer, we're finally done. We can write 1.09. So let's scroll way back up here and write in our proper blank, 1.09. Going to our next point, we know our degrees of freedom now are going to be 10. We're looking at DF total. So we can look up our cutoff point. So let's go ahead and do that. And here we go. Our calculator says 0.05. And degrees of freedom is 10. We'll calculate. And our critical value of T right-tailed, and now remember, critical value just means cutoff point. Right-tailed is the same as high, and so we use 1.81. And so this equals 1.81. Now, we usually draw that picture. I would say that if you feel really comfortable with understanding what we're doing with these things, you don't need to draw pictures anymore. And if you have any still doubts about this, the picture will be really helpful. So remember, we're using a mean of 0 here. I'm writing it on top, I guess. We still have these same standard deviations of 1 and 2, and I'm just approximating -1, -2. None of this is any different than what we've been doing. Our cutoff point is 1.81. So let's draw that in here. It's going to be between the 1 and the 2, a little bit close to the 2. Let's get a skinnier. Let's just write 1.81, nice and dark. I think I picked a weird pen up. I think I picked an arrow pen. That's very exciting, but we don't need that. So let me just get that out of there. And 1.81. And so we're looking for a sample score that's going to fall up here in this region. And so if our sample score is up there, then we say that we reject the null hypothesis. We just have one less calculation to do, is to calculate our t-score, our standardized score for this. And so mean 1 minus mean 2, we can, let's just do the calculation right up here, equals, get my purple pen out again, equals, our mean for sample 1 is 8.5. Our mean for sample 2 is 6. We divide by that big long standard deviation. We can't shorten it when we actually do the calculation, but I'll shorten it for writing it out here. I'll put the approximately sign maybe, so we know that I've shortened it for the purposes of this calculation. And so we have 8.5 minus 6 is 2.5 divided by 1.09. And the actual answer to that is 2.2981928. I'm just going to write 2.30. Whoops. All right. Equals 2.30. And if we plot that in here, we can see that 2.30 would be right about here. And so our decision would have to be that we reject HO, and we conclude that puppies trained with affection
Just no.
have higher, yeah, it's slow today. I don't know what's wrong. Higher responsive, I'll try to close some things in a minute, than puppies trained. It'd be good when we get into Excel with punishment. You'll see in my examples that typically when we do independent t-tests, we write the means in after each population. So puppies trained with affection have higher responsiveness, and then I'd write the mean there. Mean equals 8.5. Then puppies trained with punishment, and I'd write the mean here, mean equals 6. And then I'd write the last parenthesis where we put the statistic, T, and then this little 10 equals 2.30 P less than 0.05. So that's how we would solve this on paper. Now, what I want to do is to show you a nice template for doing this in Excel. And I've provided you with this template, and I'd like to show you how to use it today. And whoops, let me get out the student template. I made a student template for you, so let me grab that. So I always try to think of when I'm showing these answers, how can I make it meaningful for you? And so if you have a template, so I made you a template that looks like this. And I made one for large sample sizes and one that'll be a little easier for small sample sizes. And so we'll just eliminate these scores from this old problem. I'll do that in yours as well. I'll save this so that it'll come up in yours too. And so now we just delete. Okay, so what we're going to do is just fill in the information. And so I'm going to start by writing a short version of the research question here. So what you'll actually get is going to be a longer version. So I'm just going to write do. We'll see if we get the same answers when I work it a second time. Puppies trained with affection have better, I think I had, better responsiveness to people than puppies trained with punishment. And I said use p-value equals 0.05. So now the problem is here, and I've written out the steps. So this is your template. I'm going to erase everything that we've done when I'm done here. So hang on a second. I'm going to copy this and undo it and save it. And this is what you're going to find when you come in there. So now this is saved, and I'm not going to save what we're doing here. All right, so here's our question. We can parse the problem now. We know population 1, we've done all this already. Puppies trained with affection. We know population 2 is puppies trained with punishment. We know the dependent variable is responsiveness. We know the tails, we've talked about this already. That's why I'm not parsing it differently. One-tailed high, and we know the hypotheses. And in this case, it's kind of hard to write. It's not hard, but it's a little tedious to enter the actual Greek symbols. So you can just write out mu1, and it's possible to make these, to go into your font and make these small little cases. My computer's been doing this weird thing for me lately where it takes a minute to do things like that. It'll come right back in like 30 seconds, but it takes sort of a long time to come back. I have to look into the problem. It'll be back in just a second. So what I'm saying here, though, is you don't have to look around for the little mu symbol, even though it's here and it's possible. It's a little tedious and you don't need to bother with it. It's okay with me if you write it just as it is there, mu1, or if you want to go into your font and type the subscript like that, you can do it that way, but it's not necessary and it's not required. So we'll simply write H1, mu1 is greater than mu2. So you can see how you can make that, kind of, let me get rid of this subtext now. It won't do that again. It'll come out nice now. All right. And then we can put a semicolon and write the null hypothesis, but don't forget this stage. mu1, and it's easier to just write equal to mu2. So that's how we do it. Our comparison distribution I showed you earlier, we can write it in the sentence now. We're looking for a t distribution of differences between means with a center mu, we can use that again, equals 0, normal shape, and spread S differences. We can just write it like that, equals, and then we have to fill that in. So let's stop here and go down and start our calculations. So in this case, I gave you the data, and now I can just easily copy them out of the problem. I can just copy these data. I use Control C, but you know how to copy in many other ways. I can paste them in here, and I can do the same for the next group. I can go back and get the data and paste them in. I'm just clicking in the first cell you can see and pasting, and I'll get rid of person 7 here. We don't have any people, and I'll get rid of this. And now we have just what we need to have here. So these are our raw data, and we can go ahead and work our calculations. I'll name the group so I remember what I'm talking about. This is the praise and affection. And this is the punishment. All right, so let's go ahead now. Our basics, our N1, I already added that is 6. Our degrees of freedom is, I always like to set up a formula for these things. It's just my preference. Our mean for sample 1, we'll just do it the quick way. Let's just type in average and select the cells we want to average. I did that by just placing my cursor in the first cell, pressing my left mouse button and holding it down. To calculate the sum of squares, we need to go ahead and put the mean in each of these. I've already done that for all of these, so let me just add it for this last puppy. Now we have that done. To calculate the deviations, we're just going to write equals. That's what we always do when we start a formula. We'll take X by clicking in the first X. We'll put our minus, and we'll click in the M cell. And there we are. There's the first deviation. Let's go ahead and figure out the deviation squared for that one. Let's go in and type our equal sign. Let's click in the deviation, put the times sign, which is the asterisk, click in it again. That'll square it for us. And there we have the 2.25 that we used in our other problem. Now we can simply highlight these 2 cells, hit copy, and then highlight the next puppies where we want to paste it. And now we can just hit paste. And we have all those deviations squared. And then we can go in and simply type our sum of squares, which is the sum of all those values, which equals the sum. So I'll type equals. You can see it in the formula bar here. Equals sum, put my opening parenthesis, and select all of the cells that I want to sum. There they are. They're all circled. So I can hit enter, and we get our 25.5. And we can do one last step here because we don't need any new data to do this variance for sample 1. So we can simply do equals to show a formula. Let's click in the sum of squares and divide by our degrees of freedom. And there we have the variance. We can do the same over on the other side. Let's go ahead and type in the degrees of freedom. Equals n minus 1. We could also just type in 5. We can calculate the mean. Equals average. And let's select all of these. In mine, I have it set up so it'll automatically fill that in here. So that's done for us. And that's in your template as well. So, but you might have to take a look at it. Always take a look and make sure it's right. Let's calculate our deviations. Equals x minus m. Let's calculate our deviation squared equals deviation times deviation. And let's copy those two cells and paste them down. Now we can calculate our sum of squares for sample 2. And we can calculate our variance for sample 2 equals our sum of squares divided by our degrees of freedom. And so there we go. We have some nice information. Now, in order to calculate what's next, this percent, we need to have DF total. So DF total we'll put up here. It is DF1 plus DF2. And so let's type equals, and let's put the DF1 plus, and let's go ahead and get DF2. And now we have that down, and so we can now calculate the percent. So let's go ahead and get this percent for sample 1. We'll type the equals, and let's click in DF1, and let's use the divide and put DF2, and we get 0.5. And I'm going to do the same here. Equals DF2 divided by DF total, and we get 0.5. Now, we cannot go to the next step because look what it says we need. We need to have variance pooled. So let's go ahead and use this formula up here. All of these in the center are referring to the total for the comparison distribution itself. So let's go ahead and figure out the pooled variance. Remember, which one are we going to use? We couldn't decide, so let's kind of average them, but let's make sure that we know if the sample sizes are the same. So let's type our formula equals parenthesis. You can see it appearing in the formula bar. And let's take %1 times variance 1 and put a closing parenthesis. And now let's sum it plus, and let's do %2 times variance 2. Put a closing parenthesis. I can see here that I forgot my opening parenthesis. Let's see what happens if I try to do it like this. It gives me an error message. It says it tried to correct it, and it tried to correct it by eliminating the parenthesis, which would actually work fine because by default, the program will always multiply before. No, it'll add before multiplying. So this is a bad correction. So let's hit OK here, and let's just correct it ourselves. We need an opening parenthesis here. We need to have it multiply before it adds. And that's what the parentheses do for us. So let's hit enter and we get that 3.55. Now we know what variance to use for calculating the distribution of means. So let's go ahead and calculate the variance for the distribution of means. And that's just variance pooled divided by the n for sample 1. So equals, here's the variance pooled, and let's divide by n. And let's do the same over here. Equals variance pooled divided by n. Now we're in pretty good shape. All we have to get is the variance of differences and the standard deviation of differences. So we just sum up those two variances we just did. So equals the sum of variance for the distribution of means ones. And I can put a plus sign or I can just put a comma. And there we have it. We'll put a closing parentheses. It's going to sum those two cells. It looks right. This one is going to be summed with this one. Let's hit enter. We get 1.18, same as we got before. And let's go ahead and calculate the square root of that to get the standard deviation for the differences between means. And that, as you'll recall, is just SQ for square, RT for root. What do we want to get the square root of that variance of difference scores? And that's 1.087811. And so we can fill in the 1.09 up here. And so here is what we had done before, and we can just fill in 1.09. But do remember, if we're going to calculate, we have to use all of the digits. We can then look up our cutoff scores, which we already did before, but we'll just write out our criteria again. So we're looking at a T distribution for DF equals 10 degrees of freedom, and P value is 0.05, and we're looking at one-tailed high. And we know that our cutoff point was 1.81. Am I right about, am I remembering right? Our sample t-score, we can just calculate it right up here. T equals, it automatically calculates here, T equals M1 minus M2 divided by S difference. And that equals, we already calculated that before. Let's do it down here just to show you, equals, and let's put the mean for 1, subtract the mean for 2, and divide by S difference, which is right here. And we get that 2.298193. I can just write 2.30. And that should be good there. We can make our decision, reject HO, and we can conclude. Puppies trained with praise, affection, have higher responsiveness to humans. And then let's put down the mean. Mean equals 8.5. Then puppies trained with punishment, and their mean equals 6. And then I'm going to just go to the next line because I'm running out of space here. So I'm just going to go to the next line and write T equals T, and then the degrees of freedom 10 equals 2.30, excuse me, 30. And then we'll write P, the probability of getting that score by chance is less than 5%. And that's the end of the problem. We'll put a period to mark the end of the sentence. And what you could do to turn this in is you could submit this spreadsheet, which would be great because I can see your formulas then. So you could just submit the spreadsheet. You could, so let me clarify this again. If you're going to use this template that I've provided, what you should do is download it if it's listed for you, and then you should copy it and you should paste it into a new tab and label the tab. And so the next problem we solve, I'll go ahead and do that. So I'll be using it just as I recommend you do it. So what questions do we have about any of this? I'm going to pause for, I got one problem done. Oh, I got 2 problems done. And then I'm going to do a really quick final problem just to demonstrate this one more time.
When I upload my assignment, Excel, to Blackboard, it comes out like all, what do you call it? In different places. It doesn't come out like how it looks.
Does it come out? Yeah, it comes out sort of in a black and white. If I download that document, I can see your formulas. So if I had questions about what you were doing, and I would download it.
Yeah, like it comes out in different places on different pages.
You know what you might consider doing is, this is what I do when I post the answers up, is I kind of zoom out like this so that the whole thing is visible on my screen. And then I get a screenshot of it. The screenshot, by the way, if you're using a PC, is called snipping tool, and you sort of have to look for it. So this is another thing that another way that you could do it is to get a screenshot of it, and then you could either save this as a JPEG, or else you can paste it into a Word document. And I'd actually appreciate if you pasted it into a Word document. But if you're going to paste it in, so now it's copied, and you could go ahead and get up a blank document. But the only thing you have to do is change the layout. So you have to make sure that, that you have a landscape orientation, because it's wider than it is tall. And then you can paste it in and submit it that way as another possibility.
Okay.
So it's just, I do like to see your formulas. So if you do that, attach both your spreadsheet and do this little pasting process, and that would probably be easiest for me, but we're just getting through this process. So I've been extending a lot of latitude in terms of how you present your work and your answers.
Okay.
So now I'm going to exit out of this and I'm not going to save it. So I'll be back to the template that you will be getting. I'm going to open that again. So yours is going to open this very document in my file. So what I would do if I was you is I would do File, Save As, and then maybe name it. So let's name it. I'm going to name it temp because I don't want to save this. Whoops. Because I don't want to save it long. So I'm going to just save it and I'm going to name it temp. And then I'm going to call it homework, you know, chapter 08 or something like that. And then your name, you know, Kyle, something like that. So let's just put this in here as if it's yours and then I'll delete it when we're done. So let's get another question up. I have a lot of questions we can use for examples here. Let's do one with unequal samples. And I'm going to do this problem. Are people who prefer pet cats to pet dogs more introverted than people who prefer pet dogs? So do people who prefer cats over dogs, are they more introverted than people who prefer dogs? This is the problem we're going to work on. So let's pull it up in your template. I'm going to just paste the problem in there. And let's go ahead and get the data just so we're all set with that. And by the way, this is what I meant to say. So here's your template. So let's copy it. I'm going to undo that. Let's copy this page. To copy it, you click in this triangle in the upper left corner. And if you're not remembering all this, just turn this video on and watch it again. So you copy it, then you use this plus sign to add a new page. And let's put the new page in here and let's give it a name. I'll name it introversion. Or you could name it problem 1. Introversion would be more helpful to me, to tell you the truth, but see if it's still in there. Nope. Okay, so let's go ahead and get that back in. All right, so there is the problem that we're working on. And let's get the data too. And then we're going to do a really quick solving on it. And this will be the last example that we do. So what we're doing is we have group 1 cats, and these are the scores. And let's put them into our new sheet that we just made. I don't know if I got it quite right here. Yeah, that's how I had that set up. So let's type in cats, cat prefers, just so we know what the groups are. Let's go ahead and get group 2, and then we'll work through this whole problem. Nice small samples. I did an example with large samples that I think is a pretty decent recording. So you can go ahead and use that if you have larger samples. Whoops, let's undo and kick it up here. I'm going to get rid of all the rest of these because we're not using them in this problem, and we should be set. So let's go ahead and do our work. Population 1, people who prefer cats. You can shorten it a little. People who prefer dogs. Our dependent variable is introversion. Our tails, it looks like I see this word more, so I'm going to say it's one-tailed, and more suggests more, so I'll put one-tailed high. And our hypothesis, so H1 is going to be the same as they were before, actually. Mu1 is greater than mu2. And our null hypothesis, mu1 is, I'm just going to write equal because it's easier, is equal to mu2. Our comparison distribution, we know it's going to be a T distribution. T distribution of differences between means. So doesn't mean you're looking up anything different. It's just that that's what the distribution represents. With center equals 0, normal shape, and S difference equals, and we'll fill this in. Let's go ahead and do our calculations. So n equals 5, degrees of freedom equals n minus 1. Our mean, we can calculate the average. We'll just type equals average and then put our parentheses and get that. we can calculate our sum of squares equals, equals equals x minus m, x minus m, and we can calculate our deviations squared equals our deviations squared. All right, and now we can simply copy this down, paste it to the remaining cells, and then we can go to calculate our sum of
Right.
squares. So equals the sum of these squares, and we'll hit enter. And we can calculate our variance, which is simply the sum of squares divided by the degrees of freedom. So now we're set with all of our basic information on this side. We can go ahead and do the same on the other side. So in this case, I seem to have not gotten our scores here. So let me go ahead and get those. Here they are. So there are our scores. And let's go ahead and get our degrees of freedom equals 2. I'll just type this time. Let's get our mean equals the average of these. Let's get our sum of squares. Now, because I'm almost out of time, I'm going to do a little cheat. I know that when I copy a cell like this, it references the 2 cells to the side of it. It does that automatically. So I'm just going to copy the formula from here. Let's paste it over here. Now I don't have to rewrite it all. And you don't have to do this. It's better to write it out initially, but because of our time, I did it that way. So now you can see that it calculated those out a little more quickly. And I'm going to do one more cheat. I'm going to take the formula for the sum of squares here. And let's see what happens when I copy it and paste it here. Let's see what variables it holds up. Let's look. It looks like it's getting the sum of all the values here, which should be correct. So let's take it and let's go ahead and get the formula for the variance and paste it here and see what it does. And when I highlight it, I can see the cells it's doing sum of squares divided by degrees of freedom. So that's also correct. So those 2 it worked for. Something you can do if you choose to, but when you're first starting, it's better not to. Let's go ahead and get our degrees of freedom total equals the sum of df1 and df2. We can calculate our percent. Now we have the information equals df1 divided by df total. And we'll do the same over here. Equals df1, df2 divided by df total. Now we have our percents, so we should be able to calculate out our variance because all we need are the 2 variances and the 2 percents. So let's type in the formula equals %1 times variance 1. And we're going to sum that with opening parenthesis, %2 times variance 2. Let's look at it and make sure we got the right cells. %1 variance 1, %2 variance 2. I've got the plus sign, I've got times, I've got the right parentheses. It should calculate correctly, and we get 17.6667. Now we're ready to get the variance for the distribution of means for each sample. So we get equals variance pooled divided by n for sample 1. And we get equals variance pooled divided by n for sample 2. And so in this way, we've taken the information from both samples to calculate out the variance for the distribution of means for each sample. Now we simply calculate out the variance of different scores by summing those 2 equals the sum of the variance for mean 1 plus the variance for mean 2. And so here we have it. And I should have said the variance for the distribution of means for sample 2. And now we can take the square root of it and we're done with step 2. Equals square root of this end parenthesis, and we get 1.909043, which we'll use for calculations. But in the meantime, we can fill in 1.91. Our cutoff is going to be T distribution of differences between means. Look at that, it typed in half my answer there for me. All we have to fill in is the S difference. Oh, and it filled in that too, of 1.91. It's because I did this earlier. No, that I did. I did that all wrong. We're looking up the T distribution. The T. I took that automatic copy, but that's not what I meant to take. I meant to write out the T distribution with DF equals, what was our DF total again? It was 6. Yeah. DF total equals 6. P value equals, it says 0.05 in the problem. And what other information? 1-tailed pi equals, let's get up our calculator and find out. We have the p-value 0.05, and we'll change our degrees of freedom to 6. And we find that our cutoff point is now 1.94. Where am I here? Here we go. 1.94. Our t-score for our sample. And if we wanted to draw that out, we can. Our t-score for our sample is just M1 minus M2. And we divide by S difference. And that equals, let's go ahead and do our math down here, equals M1 minus M2. Get my parentheses in there. If you don't get your parentheses right, you won't get the right answers. Divided by S difference. And so we get, wow, a t-score of 4.7144. Think about if that makes sense. 4.71. And so it looks like in this case, we would see that our t-score is considerably higher than our cutoff point. So we would decide to reject HO and conclude that people who prefer cats have significantly higher introversion levels than people who prefer dogs. But because that is so high, I just want to make sure I did everything correctly. T6 equals 4.71. P is less than 0.05. And I want to make sure I didn't make any dumb mistakes here. So, and then we would also type in the means there. We would type in M equals 42 for the first group. And for the second group, we type in M equals 35. Enter. Now, I just want to take a look at this and make sure that it's all making sense to me. So we had 42 minus 33. So that's quite a big difference, actually, in those mean scores. So that could be right. And all of my formulas look, I mean, when we looked at each one of them before we ran them, it didn't look like we made any silly mistakes in our formulas. So our sum of squares, does that look right? Or excuse me, or some, yeah, that looks right. So everything does indeed look right, and we can do it logically too. If we calculated all this right, then we're looking at a variance of 1.90, and we can think of if we have a difference that's, our difference was 7, we divided by 1.9. Yeah, so that looks like that's all correct. So it looks like this is what we conclude then. So we have our dog lovers as being less introverted than our cat lovers. And that would be the end of the problem. And then to submit it, you probably would want to submit your spreadsheet with your solution so I can look at your formulas. And then you could also paste it into a Word document, which would really be helpful for me to see how you're doing with this. So I hope that this process is clear. I did a nice full example using a large sample size. And I have that recorded for you under the practice problems. So you have 5 practice problems, 4 with small samples and 1 with a large sample. And then you have you have 5 practice problems, 4 with small samples and 1 with a large sample, and then 4 homework problems that are just the same. But you can see how quickly they go once you learn what you're doing in Excel. And so I encourage you to use it. I'm not going to downgrade you if you don't, but I really encourage you. It'll be a tool that you'll have for value later. Any questions or comments before we sign off?
No,
Yeah, thanks for responding. Is anyone still here? I haven't been looking because it's hard to do so many things at once. All right, yeah, we do have a good number of people here. Yeah, so any of you, are you guys getting in there with Excel? Let's say something before we go.
yes.
Yeah, it's pretty cool, isn't it? Makes it a lot easier. So I didn't
Yeah.
see a lot of new work from you. I graded a lot earlier this week or last week or something, and I had very little turned in this week. And yet I still have a lot of students working on chapter 7. So I really encourage you to just keep plugging along, turn in your work. Don't worry about the late passes anymore. We're going to be, moving on to correlations in our next class. So I really suggest that you get going on this stuff while it's fresh in your mind. And the template is there for you. You should have everything you need. And then when you're doing this, think about me if you could, and how hard it is to grade all this. And that's why I wanted to give you a template to organize everything for you. Okay. So with that, I'll sign off. So maybe just pop in and say goodbye to me, or I'll stop my share so we can see each other.
Have a good day, Professor.
Thanks, Arthine. And you
Bye,
too.
Dr. Ross.
Thank you. Bye-bye. Bye, Shanielle. Bye, Kiana. Kyle.
Bye, Dr. Ross.
Bye, Doris. Yolanda, hang out just a second again. I want to just get your phone number because I feel like I want to touch base with you, so I make sure and know when you're coming and Yolanda, are you in here with us? Kyle, do you have any questions I can answer?
Yes. I wanted to ask why I got a 4 as my grade for my practice problems.
You only did 2, unless I saw something wrong.
No, I did all of them.
Okay, I didn't see the rest of them. So let me look at what I'm seeing in my view. Is it maybe the spreadsheet problem?
I don't know. I uploaded on practice 8.
Okay, yeah, I can take a look at that. I gave you a 2 because you did really well with the ones you did, but I only saw 2 problems. I think that's why, if I remember correctly. Whoops, I went into the wrong thing here. Let me get into our class here. So we're looking at practice 8. And here is you.
Can you share your screen?
Yep, I just need to make sure there are no other students' names visible for the sake of their own privacy. So I'm going to click on view grade details and view attempts. And now I'm in yours, so now I'll share my screen.
Okay.
All right, so let's take a look and see if there's something that I missed.
You got to go all the way down.
Yeah,
There they are.
Okay, so I think I might have, yeah, is this what it does to you when you submit it then?
Yeah, I have no idea why it's like that.
Yeah. Yeah, see, this is where I got hung up. That's where I went, is I think I stopped when it started getting weird that way. I thought that was the end.
Okay.
So I'm sorry about that. Let's correct this right now.
Okay.
So this is just practice. So
Yeah.
I usually just look to see, I'm not looking for right answers. I'm looking for you to identify your problems. And here you did. Okay. So here is where you made your comment. If you're able, maybe make your comments in a different color because it's harder to see. Okay. So
Okay.
this one for problem 3, you thought it looked like,
Yeah, because on problem 3, when I click on the link to practice problems, when I go on that one
yeah.
and I open it, and then I scroll
So this is what I intended to post. Is this what you see?
down.
When you, maybe I
let's see.
clicked the wrong link.
Hold on really fast. Since my internet's unstable.
Sure.
Okay. Yeah, when I click onto the answer key,
Yes.
and then I go on to the actual link to problems for the questions, it's
Not this. Did I lose you, Kyle?
different than the answer key. Hello? Can you hear me?
Yes, I can hear you.
Oh, okay. Yeah,
So,
the question, it's just question 3 I got confused on because it's different than the answer key than what's posted.
okay, let me see if I did something wrong here. So what I have for the practice problems is here. And number 3 is this.
Yeah.
Oh, yeah, I've got a person 9 in mine.
Yeah. And I was trying to figure out how I got my numbers were adding up. And then I looked back at it, looked back at it, looked back at it. And then I saw that group 2 had an extra person.
Oh my gosh. All your other answers were good, Kyle?
Yeah, everything else added up and I went.
Oh gosh, I am so sorry about that.
It's
Yeah,
okay.
I'm kind of working through these as I go along, and I guess I must have just miscopied that
Yeah.
one problem. So why don't I just, let me go into the spreadsheet where I calculated it, and I'll put up a correct answer for that right now,
Okay.
but I'll also give you the credit. Okay, in fact,
Okay.
this is it right here. This is what I used. So let me just eliminate this person, and it should all calculate out just fine. Let's see if it does. And so, yeah, I'm just going to make it get a better count there.
I
So
still have trouble
now
with
let's compare it to yours and just see if you did it right. This will be great. Okay, so now let me look at what you turned in here. I think everything should have calculated out correctly. And so it looks like, so did you add the person 9 then? That's what got confusing for you because it looks
yeah,
like,
I just went ahead and added it.
oh man, okay, shoot. All right, well, thank you for doing that extra work. Did it make sense to you? Did it match my key once you added the person?
Yeah, it did.
All right, you can see where I went wrong. And
Yeah.
I'll try and think of what I can give you with your clarity and understanding the mistake. So what I think I could give you was, you know what I'll say? You
Yeah.
need to write this when you do your homework, but you can skip. Was this equal or unequal sample size? You can actually just skip problem 1. And instead of doing that, you can just write in, you told me I could skip problem 1 because I identified this problem. So when you identify problems for me, I want to reward you for it because it helps everybody. So, but you need to write it so I don't forget and think, why is Kyle not doing problem 1?
Or
You
the
see what I
next
mean?
homework.
All right.
So
very
skip
good.
problem 1 for the next homework or?
On homework for chapter 8, skip problem 1.
Oh, I already turned in the homework just before class.
Okay, well, all right. I'm not sure what I can do for you then, because I don't want to have you skip another
Oh yeah, no,
assignment.
I was just curious about that. It's
Yeah.
fine.
Oh, I am very appreciative that you
Um,
helped me with that. So,
Also, I still have kind of trouble figuring out because I'm kind of confused on the which tail to figure out, like 1 tail or 2 tail, you know?
okay,
And but I noticed that on the problem you went over today about I think it was the dogs or the puppies. Yeah,
yeah,
those ones. My tail it was still low. It was still lower than the T score. So does that still make a difference?
Do you
Because
mean
for
that
that
you
one,
used a two-tailed test?
yeah, I used a two-tailed test, but I corrected it. But I already
Well,
submitted my homework.
okay. That's actually a stricter standard. I mean,
Yeah.
and the fact that it was still significant, that's fine, but you should
Okay.
begin to understand this better. So the only time you're going to use two-tailed in our examples, in real life, probably two-tailed is used more often because it's a stricter standard. But in this case, this person only wants to know if these puppies do better. If
Okay.
these puppies do worse, this person doesn't even want to know about it.
Okay.
And so you could just, if you're looking for anything that says that they know how one group is going to do compared to another group, any word like that, you have to use the one-tailed. So just, I'm trying to make these problems pretty simple. So maybe you
Okay.
need to go back and look at each word and make
Okay.
sure you don't see anything like that and just be sure of that. But no, I won't downgrade you for that, but I want you
Okay,
to
cool.
really pay attention. So yeah, terrific work, Kyle. I am
Okay,
just
thank
really
you.
impressed with your work here. So thank you. All
Okay.
right,
I'll
bye-bye.
try to figure out how I can make the.
I had a problem for class and I guess I accidentally went into a homework problem and gave it to everybody. Oh, well, that's all
Okay.
right. Everyone gets a
All
turn.
right.
All right,
Okay.
Kyle.
We'll
See you next
later.
time. Bye-bye.
Thank you. Bye.